Okay, so we'll be taking a look at the ILS runway 5 approach plates and also just a general overview of ILS approach plates. So today, taking a look at the localizer or ILS runway 5 approach into Terre Haute. First thing we want to take a look at before we even use this approach plate is making sure we have a valid time on our approach, a valid time stamp indicating that we have the correct plates for the correct period of time. So this is going to be valid from the 27th of February to the 26th of March, 2020. So we're within that time period, so we can use those this approach plate. So next thing we want to do is make sure, obviously, we're using the correct approach, right? We either use ILS or localizer runway 5. So we actually use either or. However, typically we'll use the ILS unless we do not have a glide slip equipped on the aircraft. Also, another one that's very important, make sure you're using the correct runway, right? If we're going to an airport that has multiple different runways, 5 left, 5 right, the same number, paralleling runways, making sure it's the correct runway we're using to ensure we have the correct frequency and correct minimums, correct fixes, and so on and so forth. So next thing we'll take a look at, obviously, is going to be looking at our approach frequency, 109.7, here at the top left, indicating that's our frequency to identify the localizer, and also going to identify the glide slip as well, so it'll pop up on our aircraft C1000 or HSI, depending on what we're using. Final approach course is going to be 049. Which is also shown in the plan view down here, 049 on the plan view. So you can see that we'll be using that for our final approach course if we have to set it in ourselves, but in the G1000, obviously, it automatically tunes in to the frequency and the approach course once we load it in. Runway length is 9,020. Touchdown zone elevation is 578, and airport elevation, obviously, as we know already, is 589. And we'll talk about why we have the touchdown zone elevation here in a moment, why that's important. So ADF and DME is required for this approach, obviously, is shown here in our approach plate notes, indicating due to the fact that we do have a VDP for the localizer approach, which we'll talk about in a second, which is only identifiable through the Terre Haute view or DME distance away from it. So next thing we'll take a look at is the approach plate notes. First thing that kind of stands out right here is going to be our non-standard and non-standard ultimate minimums are applied. So non-standard takeoff and our non-standard ultimate minimums do apply. So we'll have to go into the TERPS chart to figure out what the difference is there based off of, obviously we'll no longer have the standard 802 and 602 for the precision and non-precision, right? Because technically we have either a precision or a non-precision being the ILS or the localizers. So 802 or 602 depending on which one we're using. And then also it has approach surveillance radar minimums as well, so we'll have to go in there and figure out what our minimums would be for that in the event that we had a no gyro approach into the airport. So going into the notes, you can see that the VDP is not available when using the Paris altimeter setting. That's because if we were to not get the local altimeter setting for Terre Haute, we'd have to use the altimeter setting in Paris, which if we have an altimeter setting from a different airport, it could cause a adjustment in the altimeter setting based off a difference in pressure from Terre Haute Airport versus the airport in Paris. So making sure if we're not using an on-airport altimeter setting, we'll have to use a different one, and that could adjust the actual altimeter setting based off of where we're at and whatever pressure region we're in. So if we don't have the Paris altimeter setting, or if we don't have the Terre Haute altimeter setting, and we have to use Paris, we can't use the VDP for this approach. And when the local altimeter setting is not received, we're going to have to use Paris altimeter setting, and this also would have to increase our decision altitudes, all decision altitudes, by 61 feet, and all minimum descent altitudes by 80 feet. So that would apply to us as well, and that's a really important aspect for us to know. If we go into the airport and there's not a local altimeter setting being received, that's going to adjust our minimums. So we'll have to raise 778 feet by 61 feet. And also, if we're using the localizer, we'd have to raise our MDA by 80 feet. And that would make a difference in what our descent altitude, minimum descent altitude or decision altitude would be. So, continuing on, and that would be 80 feet for the straight-in localizer 5 for the MDA, and category C and D visibility range, or RVR, would increase to 4,500. So currently our RVR on these approaches, for category C and D is 3,500. If we do not have the altimeter setting, we're actually going to raise that by 1,000 feet to 4,500. So for inoperative ILS, or excuse me, ALS, which is our approach sliding system here that we can see, we have the Mausers A5, and we can figure out more information on the A5 Mausers in the TERPs. In the very front of it, it actually shows you each individual approach lighting system, the colors of the lights, what they're laid out, the distance, how long it is. So it gives you a more detailed look onto what exactly we're looking for, rather than just seeing this little picture here and trying to look for that on the ground as we're coming into the airport. So if we had more questions on the type of approach lighting system we have, we can go into the TERPs and take a look at that. So for an inoperative approach lighting system, so if we were to see that the Mausers were inoperative, we would increase the straight-in localizers category C and D visibility to RVR of 5,500, so to go from 3,500 to 5,500, so to actually increase it by 2,000 feet RVR if we did not have an approach lighting system that was operational. When the Paris altimeter setting increases, and when we're using the Paris altimeter setting, we have to increase our straight-in runway 5 categories, all of the categories, to 4,500 RVR. So if we're using the ILS, all category minimums for the RVR is 2,400. If we do not have the Paris altimeter setting, we're also going to increase our RVR to 4,500 on top of the increase of our MDA of 61 feet. So we'll have to increase our decision altitude by 61 feet, and also increase our RVR by over 2,500 feet, or excuse me, 2,000 feet, to get us up to 4,500 feet RVR. So for the straight-in localizer 5, when we're using the Paris altimeter setting, we're going to increase our visibility to 1/2 mile rather than an RVR visibility. So we'd actually have to have 1/2 mile reported for us to use the straight-in localizer 5 approach when we're using the Paris altimeter setting. And then all category visibilities for the straight-in runway 5, all categories visibility will increase to 1/2 mile. So actually, all the categories, regardless of A, B, C, or D, if we're using the Paris altimeter setting, we no longer have 2,400, 3,500. They all go to just straight 1/2 mile visibility reported, or we cannot legally shoot the approach. Next, we do have 2 small asterisks here indicating there's a note we want to be aware of, and it's indicating that RVR of 100 or 1,800 is authorized with the use of flight director, autopilot, or a heads-up display to the decision altitude. So in the aircraft, you may have a flight director, which is essentially a dumbed-down version of an autopilot. It's not actually controlling the airplane for you. It's on the G1000 or the screen that whatever is installed in the aircraft. It has a synthetically displayed miniature aircraft that you can follow that will take you to your desired heading, altitude, decision altitude, and whatnot. Your autopilot, which is obviously flying the aircraft in lieu of the pilot, or a heads-up display, which is a glass panel that comes down from the top of the cockpit and it displays all essential information like an HSI, an airspeed indicator, an altimeter, right in front of the pilot, so you wouldn't have to actually look down at the screen. You can continue to look ahead towards the runway for the entirety of the approach. So if you have any of those, you can actually decrease your RVR to 1,800. So we changed that now to 1,800. So we go from 24 to 18 now if we have any of those 3 components on the aircraft itself. So going back up, finishing up on the notes here, and that is not available when we're using a Paris altimeter setting. So essentially that RVR reduction is no longer valid if we do not have a local Paris altimeter setting. Obviously next to that is showing us our approach lighting systems, the Mausers. Gives you a small little detail what we're looking for, but not too much. So if you want more information on that, you have to go into the TERPs. We have our textual outline of our missed approach procedure, which is a climb to 2,300 direct to the terror work tag and hold. We'll go into that here in a moment. And down here, we have all the frequencies that we could possibly use for the approach, or when we get to the aircraft on the ground as well. So on the left here, we have VHF frequencies, and on the right, we have UHF frequencies. And the difference between those is obviously in our aircraft, we use VHF in the airplane, but for military aircraft, they use UHF frequencies. So making sure they're both outlined for any aircraft who may be doing this or conducting this approach. So going down to the next portion here, in this area here is called the plan view, indicating it's an overhead bird's eye view of what the approach we can expect, right? So we have a couple of different ways we can actually conduct the approach. We have 2 initial fixes, work down here, which is 35 miles away from the, I believe that's the Bible Grove VOR. And also we have the outer marker, which is also can be our initial fix. So either one of these can be used as an initial fix. Or we can join the approach via radar vectors to the final approach course, and then once we are established on the final approach course, that would be our initial fix, and then we'd fly inbound to our final approach fix, which is either for the ILS would be glide slope intercept at 2,200 just prior to or it would be at indicated by this Maltese cross for the localizer approach. So if we're flying this full ILS procedure, this is one question that comes up pretty commonly to a lot of students is, obviously if we take off from runway 23 and we want to do the full procedure, all we do is just fly direct to via the localizer outbound from runway 5, or excuse me, runway 23, hit fly outbound for 1 minute. If I can write that maybe. I'll just delete that, it's kind of hard to write. So outbound for 1 minute, then we do a procedure turn to a 274, outbound to a 274. We'll look in here, this barb indicating we want to turn away from that barb, make that left-hand turn back inbound to reestablish our final approach fix inbound. So the reason that we turn away from this barb is because if we turn to the right, I'm going to clear this out, if we turn to the right, what's it going to do? It's going to put us closer to our final approach fix. We want to give ourselves as much time as possible to get ourselves established on this localizer, inbound to and then conduct the approach, get ourselves set up, give ourselves that 3 nautical mile final for the GUMPS check. So if we don't do that, we turn inbound to the final approach fix. That's going to give us less time to continue or get ourselves set up. So always turn away from this barb to allow yourself more time to get yourself established and set up prior to the final approach fix. Because before we get to the final approach fix, we have to have the aircraft fully configured for the approach, GUMPS check complete, flaps down, gear down, ready to get the aircraft on the ground. And that has to be completed prior to the final approach fix. So if we have less time to do that, it rushes ourselves into that. So we're established back on the final approach fix. Once we make this initial turn back left to a 294, we can go then now and take a look at the profile view here, down here, that's called the profile view, indicating our altitudes that are going to be prescribed for this approach. So once we're doing the procedure turn, our initial altitude is going to be 2,300 till we're established inbound on our final approach course. So we make that left turn from a 274 to a 094 to establish ourselves on the 049 degree inbound course of the localizer. Once we're established, we'll just maintain 2,200 until we get to our final approach fix, which is obviously on the ILS whenever we capture the glide slope, which is actually right here, which is a little bit of a difference in distance away from versus where we are actually capturing the glide slope. So don't get yourself confused on that. If we turn ourselves around, we'll maintain 2,300 until we get to the final approach fix, because we actually want to be at 2,200 when we're at the final approach fix of the glide slope intercept. Same story if we're on the localizer. If we get inbound on the turn, establish the localizer, we're still going down to 2,200 until we get to which is then our final approach fix for the localizer only, just the localizer approach. So once the localizer, if we're using the localizer only, we'd go to and then descend to our MDA of 940. However, if we're doing the ILS, we'll descend to our decision altitude of 778 feet via the glide slope from this point here. So lastly, we descend past the glide slope, or past the final approach fix at 2,200, down to our decision altitude of 778 feet. Once we hit that decision altitude, right, that's the point at which we go miss. That's our missed approach point. A decision altitude, we make the decision. If we can look up, see the runway, which should be right around here, or the runway environment, which should be the approach lights, runway threshold, runway markings, anything all prescribed in 91-175. We can look all 13 or 12 of those up. If we don't see that, we'll execute our missed approach procedure, climb to 2,300, direct to the Terre Haute VOR, and we'll execute our published hold there. So we'll fly direct to the VOR, hit the VOR using our VOR green needles or GPS RNAV if we'd like to use that. Each one is acceptable. Then we'll fly outbound for a minute, make our procedure turn inbound, establish inbound, hit the VOR, and then begin our 1 minute hold pattern out here. And then wait for our either our expect further clearance time, which is our time that ATC will prescribe to us, that if we lose comms and we don't hear them, we can make our way to begin the approach again and then try it again, or we'll get further instructions from approach on which approach next they'd like us to try, or radar vectors back around to our approach course. So a common question to finish up here on approach plates for the ILS is just a couple questions that can come up pretty commonly is, one, what does this altitude here mean? Because a lot of people have questions on what this means. They've never seen that before. And pretty simple. It's that because on the ILS, right here is our final approach fix, right? Final approach fix, which is our glide slope intercept. So we'll intercept the glide slope actually prior to hitting our outer marker. So what's going to happen is we're going to send the aircraft via the glide slope on the ILS approach. However, that means we'll be descending below 2,200 before we get to So what happens is we'll be at a lower altitude than 2,200 when we hit and this is what that altitude is. 2125 MSL is going to be our altitude that will cross if we are established on the glide slope, descending via the glide slope on the ILS approach. So if we're doing the localizer 5 approach, we'd maintain 2,200 until we get to and then we'll descend to our MDA of 980. We'll maintain our MDA of 980 until either we have the runway environment in sight at the VDP, then we can continue our descent lower, or we get to our 3 minutes and 8 seconds, which is our missed approach point, using time. And that's at 90 knots across the ground, 90 knots ground speed. So if you see your ground speed with a tailwind possibly on an approach at 120, that means our new missed approach point will be at 2 minutes and 21 seconds rather than 3 minutes and 8 seconds. So don't get that confused with our 90 knots indicated, because it's all going to be relative on how fast the aircraft is getting pushed across the ground. Because if we have a 20-knot cross or a 20-knot tailwind pushing the aircraft, our ground speed is going to be dramatically increased rather than if we had a headwind or a crosswind. So if we were to get to that missed approach point and we see, or excuse our minimum descent altitude, and we were to see the runway, however, let's just say we get to, we're at we descend at our maximum rate of descent of 1,000 feet per minute, right? Because we're allowed up to that point, correct? So we get to 1,000 feet per minute descent, and we get to 980 feet, right around this area here. Excuse me, 940 feet are straight in MDA for the localizer. So 940, we maintain 940 to this MDA. The reason that we do not want to maintain or go below 940 is because there could be obstacles in this area down here that we want to maintain as obstacle clearance for the entirety of the approach. So to allow us to not descend too low too quickly, that's why we have this VDP. This descent angle over here, we can see it's a 3-degree descent angle from our missed approach, or excuse me, our final approach fix to the runway threshold. So if we descended at 1,000 feet per minute, we're going to actually start getting lower than that 3-degree descent angle. So to maintain a proper vertical separation of any obstacles, we will maintain that 980 until the VDP. And then if we see the runway at the VDP, then we can descend below 980, or we'll maintain 980 until our missed approach point and then go missed if we need to. So that's why we have a VDP, is to ensure obstacle separation and make sure we don't get too low too quickly on a non-precision approach, because the descent from the final approach fix to the missed approach point is actually at the discretion of the pilot up to 1,000 feet per minute, right? So that's why we have the VDP, is to ensure that we do not get too low too quickly, even if we did have the runway in sight prior to the VDP. So if we were at 980 at this point here, about let's just say a mile prior to the VDP, and we can see the runway right here, we'll still maintain 940. Keep saying that wrong. 940. We'll maintain 940 until the VDP, and then we'll descend to the runway if we have it in sight at that point. And then lastly, we'll take a look at why do we have the touchdown zone elevation, right? Why is that important? Well, it's important because the touchdown zone elevation is actually what our minimums are based off of, okay? So it's 200 feet above our touchdown zone elevation, TDZE. So that's why we want to know how high where the wheels will be touching down on the runway, and this minimums are prescribed in reference to our touchdown zone elevation, which is 578, not in reference to the airport elevation of 589 feet, which is actually about a 10-foot difference from the end of the runway here to this point here where the airport elevation will be taken at. So that is the difference between why we have airport elevation and touchdown zone elevation on the approach plates. A couple of quick notes in here as well, showing you the different type of approach lighting on the field. We have the A5s, we have PAPIs along every runway here. That's what those are showing your runway distance. It's going to show you your runway grade or gradient. If there's a positive or a negative pitch or slope up or down, that'll be shown on the quick reference to the airport diagram over here, where the control tower is at, where the beacon's at. This is where the beacon is. And D right here is indicating that there is distance. Distance is declared on the runway. So it's going to show you, as you've probably seen so far, when you land our 5 or 2, 3, any runways here, it will indicate along the runways how far we have left. We have 5,400, 3,000 feet remaining. So this is what this is indicating, that we do have that distance declared on the runway. And lastly, here we can also take a look at our MSA. MSA is just an advisory altitude to the pilots that if we were to be below 2,600 within 25 miles of Yino, so it's around Yino here, we would not maintain 1,000-foot separations of the highest obstacle in non-mountainous terrain. It'd be 2,000 if we were in mountainous terrain.